Good evening, everybody. Welcome back to our channel. This is Vishal. We are going to see about the Practicum 5 in our COA subject. The topic is about evaluate the performance of non-pipeline and pipeline execution for the given instruction. Okay, let's get into the program. The first program is to execute the MATLAB program for non-pipelined and pipelined execution using the same number of instruction and clock cycle time. Compare the total clock cycle and execution time and determine which method is more suitable for real-time system. As we begin, CLC and the clear statement is given and display the comparison of non-pipelined and pipelined execution. While true, the taking inputs are n, then user is taking the input, and k is also user taking the input, and t clock, the input is measured by the user. And the valid time, the statement is if n lesser than or equal to 0 and k lesser than or equal to 0 and the t clock is less than or equal to 0. Then display the value as input, invalid input value must be positive. Okay, then continue. And the non-pipeline calculation is cycle non equal to n into k. That's nothing but the t non equal to cycle non into t clock. The pipeline calculation is cycle pipe equal to k plus n minus 1. Then the t pipe equal to cycle pipe into t clock. Speed up the clock is speed up equal to t non divided by t pipe. Okay, now displaying the result, we are using the f print statement as result in new line, and second we are printing non-pipeline cycle in new line as from the non-cycle non, and pipeline cycle in new line as cycle pipe. Okay, then printing an execution time non-pipeline statement in new line, then printing execution type pipeline 4 new line t pipe. Then f speed up in 2f in speed up in new line, and lastly we are going to print about the repeat option. Then we have given a choice input. Do you want another test case? In that we are going to give yes is equal to 1 and no equal to 0. If choice is 0, display the program is terminated and break in. If the case is given as 1, then the program will be asked for another case. The output will be non-pipeline is 20, pipeline is 8, the execution time pipeline is 20, and execution time is 8. The speed up will be dividing this both, and the speed up time will be 2.5. Pipeline execution gives a better performance. So we are getting to the second question. That's nothing but run the MATLAB program by increasing a number of instructions while keeping the number of pipeline stages constant. Analyze how the execution time changes in both non-pipeline and pipeline methods. Comment the variation step in speed up. As we saw in the first program, we are first printing a CLC and clear, then k as input, which is given by the user, and t clock is also given by user, and display the increasing number of instruction. For n, the given value is 5:5:25. That's nothing but 5 into 5 equal to 25. Non-pipeline equation states this: cycle non equal to n into k, and the t non equal to cycle non into t clock. And the pipeline equation states this: the cycle pipe equal to k plus n minus 1, and t pipe equal to c cycle pipe into t cycle. And the speed up equation takes place here. Speed up equals to t non divided by t pipe, and the print instruction in new line, and print pipeline in new line, and pipeline time in new line, speed up in new line. Output for this given program is enter number of pipeline stages is 4, and enter the cycle time is 1, and increasing the instruction time is 5, and non-pipeline is 20, and pipeline time is 20. When we dividing this both, we getting 2.50, and instruction time is 10, and non-pipeline time is 40, and pipeline time is 13. Speed up equal to 3.08, and instruction will be 15, non-pipeline is 60, pipeline is 18. When we divide these both, we get 3.33. Instruction is 20 and pipeline is 80, and pipeline time is 23. When we divide these both, we are getting 3.48. And last one, instruction is 25, the non-pipeline time is 100, and pipeline is 28. When we divide these both, 3.57 will be the output. Let's get in the last program. Execute the program by increasing the number of pipeline using stages while keeping the number of instruction constant. Analyze the effect of pipeline depth on execution time overall performance. As we saw in the previous problem, we are getting the input for n from the user and t clock from the user and displaying the increasing pipeline stages. For k is equal to 2.6, that's nothing but a non-pipeline cycle non n into k, that t non-pipeline and cycle non equal to cycle non into t clock. A pipeline is cycle pipe equal to k plus n minus 1 and t pipe is equal to cycle pipe into t clock. The speed up time is calculated as speed up equal to t non divided by t pipe. Printing the four statements, that's nothing but the pipeline stage in new line, non-pipeline time is new line, pipeline time in new line from the given inputs, and the speed up is calculated here. Then the output is based on 5 or 6 types. In the first type, we are going to see output instructions 10, clock time is 1, and increasing pipeline stages. Pipeline stage 2, pipeline time is 20 and pipeline non-pipeline is 11. When we divide these both to 1.82 will be the answer. The pipeline stage 3, 30 and 12. When we divide both, 2.5 will be the answer. Pipeline stage 4 will be 40 and 13. When we divide 40 by 13 equal to 13.8. 13, 3.08. In pipeline stage 5, 50 divided by 14 equal to 13, 3.57. And in last stage, 6.0 and 15 divided by equal to 4.00. Thank you.